Before we start the exercise, that is exercise 6.3, let us first go through the theorems on similarity of triangles. Okay, the first one we have here is angle similarity, that is AAA similarity. Okay, this theorem A, B, C, D, E, F. Okay, now these two triangles will be similar if the corresponding angles are equal. That is what the theorem says. So here, if angle A is equal to, supposing this and this are equal, angle A and angle D, and angle B is equal to angle E, and angle C is equal to angle F, then triangle ABC is similar to triangle DEF. This is angle similarity, very simple. Now we will go to the next theorem, that is AA similarity, which is followed from this. AA similarity. Now AA similarity says if two triangles are such that any two angles of one triangle is equal to their respective corresponding angles of another triangle, then the two triangles are similar. Now let's suppose this is PQR and this is XYZ. Now let's say this angle and this angle are equal, and this angle and this angle are equal. If angle B is equal to angle X and angle Q is equal to angle Y, then triangle PQR is similar to triangle XYZ. Here we just need to check whether any two angles of one triangle is equal to another two angles of another triangle. If they are equal, then we will say that the two triangles are similar. Now this is to prove this, it's very simple. Since this and this are equal, this and this are equal, and so this and this will be also equal, because the sum of a triangle is 180 degree. The sum of the triangle here also is 180 degrees. So if all the three angles are equal, then by AAA similarity we will get that these two triangles are similar. Now let's see SSS similarity, side similarity, side similarity. Now here what the theorem says is, if the corresponding sides of two triangles are proportional, then the two triangles are similar. If two triangles are such that the corresponding sides are proportional, then the two triangles are similar. Now I'll show you what that means. Let's say this is 2, let's say this is 3, and this is 4. Let's say this is 4, 6, this is 8. Now here AB by PQ, AB by PQ is 2 by 4. 2 by 4 is 1 by 2, and BC by QR is 3 by 6. 3 by 6, which means it is 1 by 2, and AC by PR is also 4 by 8. 4 by 8. Here this is 1 by 2. So here the ratio of the corresponding sides are equal. So which means the corresponding sides are proportional, PC by QR and AC by PR, because all these are 1 by 2, 1 by 2, 1 by 2. This is also 1 by 2, this is also 1 by 2, this is also 1 by 2. So we say that the corresponding sides are proportional. Now what the theorem says here is, if the corresponding sides are proportional, if it is like this, then the two triangles are similar. The two triangles are similar. So that is side-side-side similarity. Now we have SAS similarity. SAS similarity. If AB by corresponding sides of AB, let's say this is DE, AB by DE is equal to, let's take this side, AC by DF. That is, we're considering this and this, this and this. Now if these two, if the ratio of this and this are equal, and moreover the included angle, that means the angle which is made by these two sides here, this and this, this and this, if angle A is equal to angle D, then what happens is the two triangles are similar. So then the two triangles are similar. Triangle ABC is similar to triangle DEF. This is called side angle side similarity, SAS similarity. So here what we just need to check is whether any two sides of these two triangles are, the ratio of any two sides are equal or not. If they are equal, then we will check the included angles. Now whether the included angles are equal or not again, and if they are equal, then we will say that the two triangles are similar. I will show you here. ABC, DEF. Okay, let's suppose that this is 4 centimeter, and this is 8 centimeter, and this is 5 centimeter, and this is 10 centimeter, and this is 50 degree, 50 degree. Now here let's find out AB by DE. AB by DE. Now AB by DE is 4, DE is 8. So 4 by 8 we get here 1 by 2. And let's see AC by DF. Now AC is 5 and DF is 10. So here again we have 1 by 2. Now what we have here is AB by DE is equal to AC by DF. Now since we are considering this side and this side, this side and this side, now we will check the included angle. That means the angle which is inclined by these two sides. So this angle. So now again here angle A is equal to angle T. Angle A is equal to angle T. Now these conditions, this satisfies the statement of side angle side similarity. Side angle side similarity. So this side and this side, the ratio of these two sides and these two sides are equal here, and the included angles, these two angles are equal. So we can say that triangle ABC is similar to triangle DEF. Now let's see exercise 6.3. Now in the first question we have State which pairs of triangles in figure 6.40 are similar. Write the similarity criterion used by you for answering the question, and also write the pairs of similar triangles in the symbolic form. Okay, now we're going to check which pairs of triangles are similar. Now let's see the first figure here. Here angle A is 60 degree, angle B is 60 degree. Here 80, 80, 40, 40. Now the angles of these triangles and the angles of these triangles, when we compare, the corresponding angles are equal. So since the corresponding angles are equal, according to AAA similarity, these two triangles are similar. So we will say here triangle ABC is similar to triangle PQR. Here the criterion, the theorem that we are using is AAA similarity. And now the next pairs of triangles. Now here AP is 2 cm, PQ 6, QR 4, PR is 5, here also BC is 2.5, AC is 3. Now we will check the ratio of the corresponding sides. Now the shortest side here is 2 cm. Here the shortest side is 4 cm. So let's check the ratio of this two shorter side. AP by QR. AP by QR is 2 by 4, which is 1. This is 1 by 2. Now the longest side here is AC and the longest side here is PQ. So AC by PQ. Here we have 3 by 6. This is 1 by 2. And then again the middle side here is BC by PR. So BC is 2.5 and PR is 5. Now let's remove the point. So we will have here 50. After point there is after this decimal point there is 1 digit. So because of that we wrote here, we have written here 10. Now this gives us 1 by 2. Now here we found that the ratio of these two sides and these two are all 1 by 2, 1 by 2, 1 by 2, which means they are equal. So we will say that the two triangles are similar. So here we will write triangle ABC. Triangle ABC is similar to triangle ABC. So here you have to be very careful when you name the similar triangles. Now you have to check the corresponding sides. Now here the corresponding sides of AB is QR. Here AB is the shortest side, QR is the shortest side. So if I start with AB and goes to this side, which is touching this 2.5, then I will start from Q to R, which is touching the middle side. So I'm going to write here ABC. So since I have mentioned here triangle ABC, now I have to write here QRP. I cannot say RQP, because if I say RQP, then I'm going from the shortest side to the longest side. So in that case, here also I have to go from the shortest side to the longest side. In that case, I have to write here triangle BAC. But since I have written ABC, here I have to give the name of this triangle as QRP. Now this here in this we are checking this. Here in this we are using the side similarity. Now for the third figure, since the length of the sides are given, we will check using side similarity. We will see whether the corresponding sides are proportional or not. Now here again we'll start with the shortest side. Here the shortest side is MP. Now, and the shortest side here is DE. So MP is 2, DE is 4. So here we get 1/2. And then the longest side, here the longest side is LP. And here the longest side is DF. So LP is 3, and DF is 6. So here we get again 1/2. Now the middle one, then the other side, that is LM and DE. LM and DE. LM by DE is, LM is 2.7 and DE is 4. So now here we can write 27/40, but we cannot cut this number. There is no common divisor, so we cannot cut now. That means the corresponding sides are not proportional. Even though these two ratios are equal, the third one is different, so these two triangles are not similar. Now for the fourth figure, two sides given here, and the included angles are given. So we're going to check using SAS similarity. Now let's see the shorter one here. The shorter one is MN and the shorter one here is PQ. So this is 2.5. Here we have 6. Now you can write 25/60 after removing the point. Now this one you can cut by 5. 5 5s are 25. Okay, 5/12. So we have here 5/12. Now let's see the ratio of the other side, other two sides. ML QR, ML by QR. ML is 5, QR is 10. Now we have here 5 1s are 5, 5 2s are 10. So we have here 1/2. Now here we can see that the ratios of MN and PQ is not equal to the ratio of ML and QR. This is 5/12. This is 1/2. Now even though the included angles are equal, that is 70 degree, 70 degree, the other two sides, that is the ratio of MN and PQ, is not equal to the ratio of ML and QR. So these two triangles are also not similar. So you will just say that the two triangles are not similar. Now let's go to the fifth figure. Now again here the length of two sides are given here. Here the sides of AB is given and BC is given, but instead of this angle it has given another angle here, which is, this angle is not included, is not made by these two known sides. So here we cannot check SAS also. So this is so for this one you will just say that these two triangles are not similar, because we don't know anything about this angle, we don't know anything about this angle here. Same here, we don't know anything about the other two angles. What we have is only one angle, so the another two angles can be of any measurement. So here we cannot apply any of the theorem here. So we simply say that these two triangles are not similar. Now let's see the sixth figure. Here we have 80 degree, and here this is 70 and this is 30. Now this angle and this angle is not given, so we can find out these two angles. Now the sum of these two angle and the sum of these three angles is 180 degree. Now this is already 80 and 70, so 80 plus 70 is 150. 150 plus 30 is 180 degree, so this should be 30 degree. Now here also this is 80, this is 30, so 110, so this must be 70. Now the sum of this triangle is 180 degree, the sum of this triangle is 180 degree. So here as you can see here, this is 30 30 80 80 70 70, that is the corresponding angles are equal. The three angles of this triangles and the three angles of this triangles are equal. So we can say that the two triangles are similar. So you will write here triangle TEF is similar to triangle PQR. This is a similarity.